I'm Dr. Saurabh Saxena. I'm working as Associate Professor in the Department of Applied Science and Humanities at ABES Engineering College, Ghaziabad. In the last video, we discussed about the concept of unit step function and its Laplace transform. And today we are going to discuss about the problems that are being asked in various examinations. So let's start. First of all, we must learn how to write a given function in terms of unit step function. For example, if the function ft is defined in the interval a to b, then this function ft may be written as ft into ut minus a minus ut minus b. So this is the way to write the given function ft, which was defined in the interval a to b, in terms of unit step function. That is, actually, we understand the definition of a unit step function as ut minus a is equals to its value is 0 or 1 when t is smaller than a and when t is greater than equals to a. So if a function is defined in the interval a to b and the name of the function was ft, so to express this function in terms of unit step, what you need to do, only multiply this function with the difference of the unit step function at the first point and at the second point. This is the way to express the given function in terms of unit step function. Also, if the function is defined in the interval a to infinite and the name of the function is again ft, so this ft may be written as ft multiplied by ut minus a minus ut minus infinity. But ut minus infinity, the value of this expression will always be 0, because instead of infinity, if it is a, then ut minus a is 1 only in the case when t is greater than a. So if at the place of a we put infinity, so this value ut minus infinity will be 1 only if t is greater than infinity, and you know nothing may be greater than infinity. So value of this ut minus infinity will always be 0. So this expression may only be written as ft into ut minus a. So we can note down here, if ft is a function which is defined for the values t greater than a, then ft may be written as ft into ut minus a only. Now, we have one question as well. The question is, if ft is equals to sin t when t is greater than pi and cos t when t is greater than 0 and smaller than pi, then express the function in terms of unit step function. So what to do? ft is defined in two parts, sin t and cos t. Sin t is defined, the value of the function is sin t in the interval greater than pi. Greater than pi means pi and infinity. So in this case, this particular sin t may be expressed as sin t into u t minus pi only. Plus, the second form is cos t. And cos t is defined in the interval 0 to pi. So unit step at the point 0, that is u t minus 0, that is ut minus u t minus pi. We can write it as sin t ut minus pi plus cos t ut minus cos t into ut minus pi. Now you can do only one thing, ut minus pi may be taken as common. So you will be getting sine t minus cos t into ut minus pi plus cos t into ut. So this is the expression of the function in terms of unit step function. In the last video, we also discussed about two formulas. That is Laplace transform of f t minus a u t minus a is equals to e to the power minus as Laplace of f t. And also it may be written as e to the power minus as into fs. And the second formula was if the function is not in terms of ft minus a, it is only ft. So the Laplace transform is given as e to the power minus as Laplace transform of f of t plus a. On the basis of these two formulas, we will be taking the next questions. So next question is find the Laplace transform of the function. The function is t minus 1 whole square u t minus 1. So we have to find out the Laplace transform of t minus 1 whole square u t minus 1. If we compare with the expression Laplace transform of f t minus a and u t minus a, because its Laplace transform is known to us, we get in the place of f t minus a, it is being given like t minus 1 whole square, and u t minus 1 is given to be ut minus a is given to be ut minus 1. So from these two things, two expressions, it is quite clear that the value of a is taken to be 1. And the functional form ft may be considered as t square, because ft minus a is t minus 1 whole square. So ft is only t square. So now Laplace transform of, we know Laplace transform of this expression, Laplace transform of ft minus a ut minus a, it is equals to e to the power minus as Laplace transform of f of t. In a similar way, we can write down Laplace transform of t minus 1 whole square ut minus 1 is equals to e to the power minus a. The value of a is 1. So it is e to the power minus a s Laplace transform of ft. Ft is t square. So the value is e to the power minus a factorial 2 upon s cube. Laplace transform of t square. So the answer is 2 e to the power minus s upon s cube. This is the answer of your question. We also may take the other question to understand it in more convenient way. Find Laplace transform of its e to the power minus 3t ut minus 2. So we have the formula Laplace transform of, see here unit step function is given to be ut minus 2, but the function is not given in terms of t minus 2. It is given like e to the power minus 3t, a normal function. So Laplace transform of ft u t minus a is equals to e to the power minus as Laplace transform of f t plus a. So if we compare this expression with this expression, so we get ft is equals to e to the power minus 3t, and ut minus a is given to be ut minus 2. And from these two, we get a equals to 2. So if we make use of this formula, we get Laplace transform of e to the power minus 3t ut minus 2. It is equals to e to the power minus as. The value of a is 2. So e to the power minus 2s, Laplace transform of f of t plus a. That is, whatever the function is, you just put t plus a in the place of t. So our function is e to the power minus 3t. So I'll be putting e to the power minus 3, and in the place of t, it will be t plus a, and the value of a is 2. So it will be t plus 2. So it will be e to the power minus 2s into Laplace transform of e to the power minus 3t into e to the power minus 6. E to the power minus 6 may be taken outside, and Laplace of e to the power minus 3t is 1 upon s plus 3. So it may be given as e to the power minus 2s plus 6, 1 upon s plus 3. That's your answer. So in this video, we are having these two problems. These are the references that have been taken. In the next video, we will be taking more problems. Thank you very much.